In this lesson, we are going to learn about complex numbers. This is in section 7.6 out of your textbook, and we're going to work problem numbers 2 through 58 even. So, as of this point in our lessons, we have learned that we cannot take the root of a negative number when this is even. Okay, so we've always said that the answer is either not real or imaginary. So now we're going to learn how we can simplify these even further by using these imaginary numbers. So the definition of an imaginary number is as follows. We use this letter I, it's a cursive I, to represent an imaginary number. So I really don't care if you use a cursive I in class or not. I just need to make sure I can tell the difference between that and a 1. So an imaginary number is when you have the square root of a negative 1. So when we look at number 2 in your book, we have the square root of negative 36. So you guys learned that we could take these numbers and break them down by using that prime factorization tree. So kind of like that, I'm going to break this negative 36 apart. So I know that 36, when I take the square root of it, it's going to give me 6. But I want y'all to see what happens when we break it apart. So when we break that negative away from that number 36. Notice how I didn't change anything. 36 times negative 1 still gives us a negative 36. So when we break this apart, the square root of 36 is 6, and the square root of a negative 1, as we just learned up here, gives us I. So notice the directions tell us to write each expression as a multiple of I, meaning they're telling you that you're going to have an I in your answer. Whenever I simplify, that's the directions, that's what they tell us to do. I'm not asking you to put it in a multiple form of I. Okay, so notice that the directions are telling us that we want to have that I in our answer. They're telling us that's going to happen. So when we look at number 4, we have the opposite of the square root of negative 25. So when we break this apart, and you won't have to do this every time, I'm only doing it just to show you. When you break this apart, it's going to be a 25 times negative 1. Well, the square root of 25 is going to give us 5. And the square root of negative 1 is going to give us an I. So when we take the opposite of 5i, they're asking us to put that negative there. Okay? Number 6, we have the square root of negative 23. So if we were to break that apart, that would give us the square root of 23 times negative 1. So when I ask you to find the square root of 23, you'll notice that you can't do that because 23 is a prime number, meaning there's nothing we can break this apart to be. So we're going to leave that under the radical. However, we can still take that negative 1 out to be an I. So we put the I out in front, and that 23 stays under the radical. Do not put the I in back because it could look like it's under the radical, and we always want it to be in front because it is considered as a coefficient, and coefficients go in front of the radical. So now let's look at number 8. On number 8, we have the square root of negative 24. So 24 is going to break down to be 6 times 4, 2 times 3, and 2 times 2. So when we rewrite this, we have 3 of the 2's, 1 3, and we still have that negative under there. So we could pull out a pair of 2's, and we can pull out this negative 1 to be an I, And this 2 times 3 is left under the radical, which gives us a 6. Number 10, the opposite of the square root of negative 192. So we're going to break that apart to be 2 and 81. 81 is 9 and 9. And we have all these 3's. So I'm going to rewrite this with our 2, our 4 3's, and our negative 1. So we have 2 sets of 3's that are going to come out, and we're going to have this I to come out. Oops. Sorry guys, I didn't mean to put that equal sign there. And then the 2's left under the radical. So 3 times I is 9i onto the square root of 2. And don't forget up here they asked us for the opposite. So that means that our answer is a negative 9i. Square roots of 2. So on number 12, they ask us to perform the indicated operation. And we have the quantity 2 plus 3i plus 4 plus 5i. So we're adding these two binomials. And before we can add any of these terms, we have to release them from the radical. So remember, there are 2 questions you have to ask yourself. 1, can I combine the 2 terms inside of the radical? Or I'm sorry, of the parentheses. No, they do not combine because they're not like terms. Second, is there anything multiplying out in front? The answer is no. So that means that this can be released from that set of parentheses. So we're going to ask the same thing over here. Can you combine these 2 terms? The answer is no. And then is there anything multiplying out in front? Other than that 1, the answer is no. So we're going to go ahead and release all of this from that set of parentheses. So now we can combine our like terms. So 2 plus 4 is going to give us 6. 3i plus 5i is 8i. Now we do have to write these in a very specific way. So standard form of an expression that includes an imaginary number is a plus bi. So a is the constant, which is the number that is by itself with no variable. And then that bi is your term with the I. Okay? So the number by itself, the term with the I, so we've written it correctly, so we're good on number 12. All right. So now when we look at number 14, we have negative 5 minus 3i, and it's plus negative 2 plus 7i. So again, you ask yourself those 2 questions. Can I combine these 2 terms? The answer is no. And is there anything multiplying out in front? The answer is no. So that means that we can release this from those parentheses. Then, can we combine these 2 terms? The answer is no. Is there anything multiplying out in front? The answer is no. So we can release this from that set of parentheses. So now we can combine our like terms. Negative 5 minus 2 is negative 7. Negative 3i plus 7i is positive 4i. Make sure it's in that a plus bi form, which it is, and you're done. You can't combine those terms because they are not considered like, so we are finished. Number 16, 7 plus 6i minus 3 plus 5i. All right, so same two questions. Just because it's subtraction doesn't change anything. We still do this the same exact way. So, can I combine these two terms? The answer is no, because they are not like terms. Is there anything multiplying out in front? The answer is no. So we can release the 7 plus 6i from that set of parentheses. Then we ask, can I combine these two terms? The answer is no. But is there anything multiplying out in front? The answer is yes. It's a -1. So that means that you will have to distribute that -1. So -1 times 3 is -3. -1 times 5i is -5i. So now we combine our like terms. 7 minus 3 is 4. 6i minus 5i is I. So our answer is 4 plus I. Number 18, we have 7 minus 3i minus -2 minus 5i. So we can't combine these two terms because they're not like, and there's nothing multiplying out in front. So we can release everything in this set of parentheses. We can't combine these two terms, but there is a -1 multiplying out in front. So we'll have to distribute. So -1 times -2 is a +2. -1 times -5i is a +5i. So now we'll combine our like terms. 7 plus 2 is 9. -3i plus 5i is 2i. So don't forget, make sure that it is written in that standard form. Number 20, it's 3 minus 2i plus 2 plus 3i plus 7i. So they got a little fancy on us. They added an additional term at the end here. We still work it the same way. You've got to remove the parentheses before you can combine your like terms. So I can't combine these terms. There's nothing multiplying out in front. So that 3 minus 2i can be released. Can't combine these two terms. There's nothing multiplying out in front. So that 2 plus 3i can be released. And since this 7i is not in parentheses, we didn't do anything with it. We just bring it on down with the rest of the problem. So now we combine our like terms. 3 plus 2 is 5. -2i plus 3i is 1i. I don't want to do too many steps at once, so I'm going to go ahead and just bring that 7i down. So now 1i plus 7i is 8i. If you wanted to skip this middle step here and just gone from this part to this part, that would have been okay. I just wanted y'all to see each step that I did. Number 22, we have 5 minus 7i plus 7 plus 3i minus 2 minus 7i. So we can't combine our terms. Nothing's multiplying out in front. So the 5 minus 7i is released. Can't combine these two terms. There's nothing multiplying out in front. So that 7 plus 3i is released. Can't combine these two terms, but there's a -1 multiplying out in front. So we'll have to distribute that -1. So -1 times 2 negative 2. Negative 1 times negative 7i is positive 7i. Now we combine our like terms. So remember the trick where you can do things a little different to your like terms? See how I'm using a different color to underline each of my terms that are like? You could also, instead of using a line, you could use this little squiggly guy. You can draw like a rectangle under it. You can surround the entire term. Like, so let's say if it's 2i, you could surround this with a heart. And then if this one was just a 5, you could just surround it with a square. There's so many things that you can do to your terms in order to visualize which ones are your like ones and which ones aren't. So we have 5 plus 7 is 12. 12 minus 2 is 10. Negative 7i plus 3i is negative 4i. And negative 4i plus 7i is 3i. Okay? Make sure it's in that a plus bi form and you'll be okay. Now let's look at number 24. We have 8 minus 2i minus, and they added some brackets in here, 4 plus 3i minus negative 2 plus I. Okay, so just to give you guys a little bit of information, you have parentheses, you have brackets, and then you have braces. Okay, so normally we're just used to working with parentheses, and parentheses mean that we're going to jump this part of the problem ahead of everything else, kind of giving it a sort of importance. However, if you have parentheses and brackets, your brackets have to come first before you can do the parentheses. Okay? Then, if you have braces on top of the brackets and the parentheses, this will come first, this will come second, and then the parentheses. Okay? So if you've got, like, let's see, say the king, the prince, and I don't know, whoever's under the prince, then this always has the most important say, this one has the second important one, and then this one will jump above everybody else. Okay? So we're going to do everything that's inside the brackets first. So act like this part of the problem isn't even here, and we're going to work everything we can inside of these brackets first. Can't combine these two terms, nothing multiplying out in front, and we're looking just in the brackets. So that gives us 4 plus 3i. And then you've got these two terms here. You cannot combine them, but there's a negative 1 out in front, so you're going to distribute, which gives you 2 minus I. Negative 1 times negative 2 is a positive 2. Negative 1 times I is negative I. Since we didn't use anything over here, we're just going to bring it down. Now we are going to combine our like terms. So 4 plus 2 is going to give us 6. And then 3i minus I is going to give us 2i. If you have to write that understood 1 in front of that I, that's okay. That's just letting you visualize what you have in front of those imaginary numbers. Since we didn't use any of this, we're going to bring it back down. So now, since everything inside of these brackets are simplified, we're going to treat them as if they're just parentheses. So over here, you can't combine these sets of parentheses, or I'm sorry, these two terms. There's nothing multiplying out in front. So your 8 minus 2i is released. Can't combine these two terms, but there is a negative 1 out in front. Remember, we're treating these as if they are parentheses. So you distribute. Negative 1 times 6 is negative 6. Negative 1 times 2i is negative 2i. Then we combine those like terms to get 2 minus 4i, because negative 2i minus 2i is negative 4i. Okay. Now let's look at problem number 26. It's the last one of this part of the section. So we have 9 minus 11i plus negative 9 plus 11i. So you've got those same two questions. Can't combine anything in here. Nothing multiplies out in front. So you have 9 minus 11i release. Then, can't combine these two terms. Nothing multiplying out in front. Since it's a positive, that means it's just a 1. And if you were to multiply that 1 times everything in here, you get the same thing. So the negative 9 plus 11i releases. So now we combine. 9 minus 9 is 0. And then negative 11i plus 11i is 0i. So you could either put 0 plus 0i, or the more popular answer, since you know that everything canceled out, would be just a 0. Okay? Now we're going to work into multiplication next, but before we do that, we need to learn our I chart. So your I chart is divided into 8 little compartments here, okay? And you start the left side by I1, I2, I3, and I4. So all we're doing is writing our i's out, and the exponents are getting larger by a digit of 1. Okay? So now, the first thing I say is, what do you say when you win a baseball game? So I always say that in math we're a little bit conceited. Everything's just about us. So when we win a baseball game, we say, I won, I won. We get all excited. So watch what happens here. We get I won, I won. So then 2, we're going to talk about negative relatives. So I always like to put this into a story. Everyone has that one relative who is so negative, they just yak, 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 yak all day long. And all they want to do is complain. And we just kind of want to shut those negative relatives up somewhere just so they can just go nag somebody else. So I always say keep your negative relatives on the inside. So notice these are the 2 inside out of these 4. So those are 2 inside. If you've got another way of learning the I chart, remembering all of its components, wonderful, perfectly fine. This is just a little story that I like to use in order to help my students remember it. So that's your I chart. We're going to use that in simplification of imaginary numbers. So when we look at number 28, we have 2i, and then in parentheses, 7 plus 3i. So this should look very familiar to you because this is your distributive property. The directions state to find each product and write your answer in standard form. Remember, we have standard form as a plus bi. Okay, we already wrote that in another page, so standard form is a plus bi. So we're doing the product, that means multiplication. So we're going to distribute or multiply that 2i by everything in the inside of that set of parentheses. So 2i times 7 is going to give us 14i. And then 2i times 3i is 6i squared. Because if you had said 2x times 3x, that still would have given you 6x squared. When you multiply those bases, you add those exponents. But now we can simplify. We have 14i and 6i squared. Well, I on the I chart is just an I. But if we have an I squared, that translates to be a -1. So what we're going to do is replace that I squared with -1. Notice everything I did was still the same, but instead of writing the I squared, I'll write a -1. So we multiply this together, 14i plus -6, but remember we have standard form, so that -6 should come first, and then the 14i, because it's always your constant first, then the term with your I. So let's look at number 30. We have 2i times 6 plus 3i. So again, we're going to distribute. So that gives us 12i, because 2i times 6 is 12i. And then 2i times 3i is going to give us 6i squared. Okay? So now replace your I squared with a -1, which gives us 12i plus -6. And then you have to write it in that standard form. So you get -6 plus 12i. Just make sure you remember that negative is connected to that 6, so it has to carry along in the front with that 6. Now looking at number 32, we have -5i times 2 minus 7i. So we're going to distribute. That gives us 5i times 2 is -10i. -5i times -7i is 35i squared. So now you replace your I squared with -1, just like we know it to be on the I chart, and then multiply. So 35 times -1 is -35, and then you need to write that in standard form. So you write your -35 first plus -10i. Or I would accept -35 minus 10i. It means the same thing. Okay. All right. So now let's look at problem number 34. This is dealing with some fractions here. We have 4i multiplied by 1/2 plus 3/4i. Okay, so we're still going to distribute. So 4i times 1/2. So I'm just going to write this out just so you guys can see exactly what we're doing. So we're going to multiply 4i times 1/2. You see how I just wrote the dot in between to signify multiplication. Plus 4i, and I'm putting it over 1 since we're working with fractions, times 3/4 i. Okay? So now to multiply them together, we would get 4i times 1 is 4i, 1 times 2 is 2, plus 4i times 3i is 12i squared, and then 1 times 4 is 4. 4i divided by 2 is 2i. And then 12i squared divided by 4 is 3i squared. Then replace that I squared with a -1, and then you multiply, and then you write it in that standard form. Okay. Moving on to problem number 36. They have switched it up on us again. We get 5 minus 2i times 3 minus I. So this is still your distributive property that we've been using for the last 4 problems, except we are going to multiply this. 5 times everything in that second set of parentheses, and that -2i times everything in that second set of parentheses. So 5 times 3 is 15, and then 5 times -i is -5i. Then -2i times 3 is -6i. -2i times -i is +2i squared. So now let's see what we can do. First off, we can combine those like terms. -5i minus 6i is a -11i, and we can replace that I squared with a -1. So now I'm going to multiply that 2 times -1 to be a -2. And now I can combine these like terms to make it 13 minus 11i. We're in standard form, so we are finished. Number 38, we have 7 plus 2i times 3 minus 2i. So again, we're going to multiply the 7 times everything in this set of parentheses and the 2i times everything in that set of parentheses. So 7 times 3 is 21. 7 times -2i is -14i. Then 2i times 3 is 6i. And then 2i times -2i is -4i squared. So we can combine these like terms. -14i plus 6i is -8i. And then I can replace that I squared with a -1. So now we multiply. Bring everything else down. -4 times -1 is a +4. And then you combine those two like terms to get 25 minus 8i. So it is in standard form, so we are finished. Now looking at number 40, we have -5 minus I times -3 minus 4i. So -5 times -3 is a +15. -5 times -4i is a +20i. -I times -3 is a +3i. And then -I times -4i is a +4i squared. Now we combine those two like terms to get 15 plus 23i. And then remember to replace that I squared with a -1. Now we're going to multiply those. So 15 plus 23i. 4 times -1 is -4. Combine those like terms to get 11 plus 23i. We are in standard form, so we are finished. Now let's look at number 42. This one's written in a different form, but we should already know what to do here. So this is written as 3 plus 7i quantity squared. So if you were to ever have like 5 squared, well, that means that you multiply 5 times itself to get that 25. So what we need to do is take 3 plus 7i and multiply it by itself twice. Now this is your distributive property, which is exactly like we just learned it a moment ago. So 3 times 3 is 9. 3 times 7i is 21i. 7i times 3 is 21i. 7i times 7i is 49i squared. So we're going to combine these like terms to get 42i, and we're going to replace that I squared with a -1. Now we multiply those two terms together to get -49. Then when you combine these two like terms, you get -40 plus 42i. Okay? So now let's look at number 44. So on number 44, they're asking for something a little bit different. We have 5 plus 2i, and they're asking us to write the conjugate of each complex number. So when we're writing the conjugate here, remember that we learned in section 7.3, which was on operations on radicals, when we were learning how to rationalize the denominator. That can be found on our video titled Rationalizing the Denominator. It's the very last problem we do there. So remember, your conjugate is always going to be the same set of parentheses with the same exact terms, except instead of having whatever sign you start off with, you use the opposite. So the answer that they're looking for on number 44 is 5 minus 2i. When we look at 46, we have 7 minus I. So we're still going to use the 7 and we're still going to use the I, but instead of writing a minus, we're going to write a plus. 48, we have -5 minus 7i. So to write the conjugate of that, we still use the -5. That's where everyone gets tripped up. Still use the -5, still use the 7i, but instead of writing a negative, you're going to write a positive. Okay? Now let's look at number 50. You have -3i. So we're used to seeing standard form as a plus bi. Well, notice here there's no a written. So if we had a 0 here, then you would say the conjugate would be 0 plus 3i, which is just 3i. Okay, so when there's just one term here, you've got to imagine that there's a 0 here, and that's going to change this -3i to a positive 3i. Okay, now we're going to move on to number 52. The directions state to find each quotient and write your answer in standard form. So we have 5 minus 3i divided by -i. So we have to multiply by the conjugate here. The conjugate here is going to be I. Because let's say it was a 0 minus I, well, the opposite would be 0 plus I, which is simply an I. So for your numerator, you're going to distribute that I into each of those terms in the numerator. So that gives me 5i and then minus 3i squared over negative I times I is negative I squared. Now, there are no terms to combine, so we're going to replace those I squareds with a negative 1. So 5i, just bring it over. Negative 3 times negative 1 is a positive 3. Oops, forgot my I. And then the opposite of negative 1 is a positive 1. So we never leave our answers over 1. So we have 5i plus 3, but you want it in that standard form. So your answer is going to be 3 plus 5i. So now let's look at problem number 54. So again, we're going to multiply by the conjugate. So your conjugate here is 4i. So we're going to multiply 4i times each of these terms. So 4i times 8 is going to give us 32i. 4i times 12i is going to give us 48i squared, divided by negative 4i times 4i is negative 16i squared. So we're going to replace our I squareds with a negative 1. So that's going to give us 32i plus 48 times negative 1 over negative 16 times negative 1. So now we're going to multiply together these and these. So we have our 32i. 48 times negative 1 is negative 48. Negative 16 times negative 1 is a positive 16. Okay, then we want to put it in that standard form. So the negative 48 should come first. Then the 32i all over 16. So now you might notice that the 16 will go into the 48 and the 32. So we still have some simplifying that we can do. So we're going to separate that negative 48 in the positive 32i, and we're going to put them both over 16. So when we do that, that 16 will go into that 48 3 times, and notice it would be a negative 3. And the 16 will go into that 32 2 times, and don't leave off your I. So your answer here would be negative 3 plus 2i. Now looking at problem number 56. On number 56, you have 5 over 2 minus 3i. So the conjugate here is a little easier to see, honestly, which would be 2 plus 3i. So when we distribute this 5, that will give us 10 plus 15i over. So let's go ahead and simplify this denominator over here. So 2 times 2 is 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. And the negative 3i times positive 3i is negative 9i squared. Notice that these two middle terms are going to cancel, leaving you with a 4 here, minus 9, and your I squared is a negative 1. So then, to multiply these together, negative 9 times negative 1 is a positive 9, and 4 plus 9 is 13. 13 does not divide into the 15 and the 10, so we know we are finished. Okay, let's look at number 58, which is the last problem that we're planning on doing on this part of the section. So we have negative 17 over 3 plus 5i. Okay, so our conjugate here is going to be 3 minus 5i. Okay? So negative 17 times 3 is going to give us negative 51. And then negative 17 times negative 5i is a positive 85. Never hurts to check. Yeah. Over, and again, I'm going to simplify this denominator over here since it's such a hot mess. So 3 times 3 is 9. 3 times negative 5i is negative 15i. 5i times 3 is 15i. 5i times negative 5i is negative 25i squared. Then, can't combine those two middle terms, or you can combine those two middle terms, and what's going to happen is they're going to cancel. So that 9 comes down, minus 25, and that I squared is a negative 1. So 9 plus 25, and then 9 plus 25 is a 34. So then we're going to look and see if anything is going to cancel. Let's see. So here it looks like, so let's see. We have the negative 51. Ooh, and that 85 should have had an I on it. Let's go ahead. Negative 51 over 34 plus 85i over 34. Thinking off of the top of my head. Ooh, we can. We can simplify because 17 is a really nasty number to work with. 17 will go into 34 twice. And we already found out that 17 also goes into 51 and 85. So 17 goes into negative 51. That'll be a negative 3. Because when we multiplied negative 17 times 3, that gave us negative 51. So we get a negative 3 here. And when you divide 34 times 2, that gives, or I'm sorry, 34 by 17, that gives you 2. So since I'm kind of rambling at this point, I'm going to actually show you what the heck I'm trying to do, see if that communicates it better. So negative 51 divided by 17 is negative 3. Negative 34 divided by, positive 34 divided by 17 is a positive 2. I'm struggling. So then we can divide both of these also by 17. So 85i divided by 17, that is going to give us 5i. 34 divided by 17 is 2. So you can either write your answer this way, or, I'm about to quit on this problem, or you would get negative 3 plus 5i over 2. So either one of these answers I would accept. Okay? All right, so that should be the rest of the video because I told you in the very beginning that we were going to go through problem number 58. But I always forget about the very end of this lesson. If you look at problem numbers 77 through 84, I actually have a little bit more to show you. So, and we're going to do all of them. So we're going to need our eye chart for this. Remember I1, I2, I3, I4, I1, I1, and then put your negative relatives in the middle. So if we were to take our eye chart and we were to continue it, well, the next one would be I to the 5th. And I'm going to draw the box here just so we know where our eye chart did end. So the next one would be I to the 5th. Well, we can break that I to the 5th up to be an I to the 4th times an I to the 1. I used 4 because out of all of these nasty numbers, 1 is the easiest to work with. So I to the 4th we knew was 1. I to the first is I. So 1 times I is I. So the next one would be I to the sixth. So that could be broken up to be an I to the fourth times an I to the second. And we can do this, guys, because when you multiply your bases, we know you add your exponents. So 4 plus 2 gives us 6. So that's how I'm breaking these apart. And again, I use that 4 because the 1, since I to the fourth equals 1, that's the easiest one to work with. So I to the fourth is a 1. I squared is a negative 1. So 1 times negative 1 is a negative 1. Hopefully at this point you notice a pattern going on. Notice how it's a repeating chart. So if you were to do I to the seventh the same way we're doing them over here, you would get negative I, and then I to the eighth would be 1. So your chart is going to just continuously repeat, 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 repeat. So if I were to ask you what I to the 259 was, well, that's a whole lot of writing your eye chart. So we need to figure out a way where we can find that number out without having to write this out, okay? So make sure you have that eye chart written down on your paper because you are going to need that. So when we look at number 77, we have I to the 10th power. Well, I could break that up to be an I to the fourth written out twice because 4 plus 4 is 8, and then we need 2 more. So I to the fourth is 1, I to the fourth is 1, I squared is negative 1. So when you multiply 1 times negative 1, you're going to get negative 1. So that's the answer we're looking for. However, there is an easier way to do this. We could take our exponent and we could divide it by that magical number 4 we're talking about. So 4 goes into 10 2 times. This 2 represents the number of times we would write I to the fourth. So we wrote it 2 times. 4 times 2 is 8. And then we have a 2 left over. This 2 is going to represent that last number we would have written. So I squared gives us the answer of negative 1. So let's try that method on number 78. We have I to the 9. So I'm going to take that 9, I'm going to divide it by 4. 4 goes into 9 2 times with a remainder of 1. So remember that I to the 1 is what we would have had left over after we wrote I to the fourth out 2 times. So I to the 1 is simply I when we look at that eye chart. 79, I to the 20th. This one is a little trickier. So notice 4 goes into 20 5 times with a remainder of 0. Remember, this 5 represents the number of times we would write I to the fourth. So if we wrote I to the fourth out 5 times, that would be 1 times 1 times 1 times 1 times 1, which gives us simply 1. So if you have a remainder of 0, your answer will be a simple 1, because that means you're just multiplying I to the fourth out, whatever this number is, that many times. Looking at number 80, I to the 15. So we're going to divide 15 by 4. 4 goes into 15 3 times. And then 15 minus 12 is 3. So we would have written I to the fourth out 3 times and our remainder is 3. So when you look at your I chart, I to the third is represented by negative I. So to be clear, this is the answer I would be looking for. Not I to the third, not 3. I'm looking for this here. 81 says I have I to the 38. They're starting to give us bigger numbers now. So if I take that 38 and I divide it by 4, 4 goes into 38 9 times with a remainder of 2. So I would have written I to the 4th out 9 times, and then I would have had a remainder of 2. So I squared is negative 1. So now let's look at number 82. We have I to the 40. So we're going to divide that 40 by 4. So we have a remainder of 0. That means we would have written I to the 4th out 10 times. So I to the 4th, I to the 4th, I to the 4th, and so on. And whenever when we say that we have a remainder of 0, we know our answer is simply going to be a 1, because every time we wrote out an I to the 4th, that gave us 1. Okay, and 1 times 1 times all of those is going to give us that simple 1. Number 83, we have I to the 51. So we're going to take that 51 and divide it by 4. So on I to the 51, we would have written out I to the 4th 12 times, and we had a remainder of 3. So I to the 3rd in our I chart is negative I. Then number 84 is I to the 61. So take 61 and divide it by 4. So you get I to the 1, which is I. Now, just for giggles, and just because we can, when we got that I to the 259 we talked about, let's go ahead and do that one. So 4 goes into 25, let's say 6 times. And 4 goes into 19 4 times. So that would have given us I to the 3rd, which is negative I. I hope that this lesson has helped you, and I wish you the best of luck.